At 8:47 in the morning, on September 25, 1942, Lieutenant Commander Sam Porter climbed into the cockpit of a VAF-4U Corsair on the deck of the escort carrier USS Sangamon. Steaming through the gray waters of Chesapeake Bay, he adjusted his harness, checked his instruments, and prepared to test whether America's newest fighter could land on an aircraft carrier. The Navy had pinned its hopes on this machine. It was supposed to beat the Japanese Zero, was supposed to turn the tide in the Pacific. What happened in the next 30 minutes would nearly kill a man and force the Navy to admit that their wonder weapon might be a death trap. Porter had flown dozens of different aircraft during his naval career. He knew what he was doing, had accumulated thousands of hours in fighters, trainers, and everything in between. But as he lined up for his first approach to the Sangamon's deck, he realized something was terribly wrong. The Corsair's cockpit sat so far back in the fuselage that he could barely see the carrier deck ahead of him. The nose stretched 14 feet in front of his position, angled upward in the landing attitude, blocking his view of everything that mattered. He could not see the landing signal officer standing on the port side of the deck, waving the paddles that would guide him to a safe touchdown. He could not see the arresting wire stretched across the deck that his tailhook needed to catch. He could not see the sailors scrambling to clear the landing area or the crash barrier, waiting to catch him if he missed the wires. He was essentially flying blind toward a steel platform, pitching and rolling in the ocean swells. Porter committed to the approach anyway. He had orders to complete this evaluation. He dropped the Corsair toward the deck, watching the carrier through his peripheral vision, trying to judge his altitude and position from glimpses caught around the massive engine cowling. The wheels slammed into the wooden deck planks with a violent impact. Then, Porter experienced something no Navy pilot had ever encountered in a carrier aircraft. The landing gear shock absorbers, called oleo struts, pressed under the force of the landing, absorbed the energy, and then rebounded. With tremendous force, the Corsair bounced back into the air like it had struck a giant trampoline. Porter slammed back down onto the deck, his tailhooks skipping over the arresting wires, the aircraft careening toward the crash barrier at the end of the landing area. He barely managed to add power and climb away for another attempt. No, the second landing was worse. The bounce threw him so high that he nearly stalled trying to get back down. The third attempt was terrifying. He caught a wire, but the aircraft slewed sideways, threatening to cartwheel across the deck. After his fourth landing, Porter taxied to a stop, shut down the massive Prato-Whitney engine, and climbed out of the cockpit with his hands visibly shaking. Sweat soaked through his flight suit despite the cool autumn air blowing across the Chesapeake. He walked directly to the assessment officers waiting on the deck and told them the unvarnished truth. This airplane was going to kill him if he kept trying. The Corsair, the fastest single-engine fighter America had ever built. The aircraft designed specifically to destroy Japanese Zeros and secure American dominance of Pacific skies, was unfit for carrier operations. The Navy had just spent 2 years and millions of dollars developing an aircraft that could not do the one thing it was built to do. They created what would soon become known as the Ensign Eliminator. The man responsible for creating the Corsair was Rex Bissell, VA Aircraft's chief engineer. Bissell was a self-made aeronautical genius who had worked his way up from draftsman at $4 a day to lead designer of military aircraft. Born in 1893 in San Jose, California, he had grown up in a mining town in Washington state, where his father worked in the coal mines. As a teenager, Bissell had worked as a breaker boy in the mines, a mule driver, and a surveyor's helper. He put himself through education and entered the aviation industry during its infancy, eventually becoming one of the first certified aeronautical engineers in the United States. Bissell had built a reputation for solving problems that other engineers considered impossible. That confidence had served him well through a career designing successful military aircraft. But the Navy's request in February of 1938 would test even his considerable abilities. The Bureau of Aeronautics had issued a challenge that seemed nearly impossible. They wanted a single-engine carrier-based fighter that could reach the maximum obtainable speed while maintaining a stalling speed below 70 miles per hour. The aircraft had to carry 4 guns, or 3 with extra ammunition for sustained combat. It had to have a range of 1,000 miles to cover the vast distances of the Pacific Ocean, and it had to be able to launch from and land on aircraft carriers, which meant surviving the tremendous stress of catapult launches and arrested landings. Every manufacturer in America received the request for proposals. Bissell looked at the specifications and made a decision that would define the Corsair's entire existence. If the Navy wanted maximum speed, he would give them maximum speed. Everything else, including ease of handling, pilot visibility, and landing characteristics, would be secondary to raw performance. Bissell chose the most powerful engine available, the Pratt & Whitney R2800 Wasp, an 18-cylinder radio that produced 2,000 horsepower at a time when most fighter engines generated half that power. No fighter in the world had ever been built around such a massive power plant. The engine weighed nearly 2,000 pounds by itself. It consumed fuel at tremendous rates, and it required a propeller 13 feet 4 in diameter to convert all that power into thrust. That propeller created an immediate engineering problem. If Bissell mounted the engine on a conventional fuselage with standard landing gear, the propeller tips would slice into the carrier deck during landing. The landing gear struts would have to be impossibly long to provide adequate clearance, making them fragile and prone to collapse under the stress of carrier landings. Bissell's solution was elegant and radical. He designed an inverted gull wing, bending downward from the fuselage at a sharp angle before sweeping back up toward the wing tips. This unusual configuration allowed the landing gear to attach at the lowest point of the wing bend, keeping the struts relatively short and strong, while still providing adequate ground clearance for the massive propeller. The bent wing also reduced aerodynamic drag at the wing-to-fuselage junction, adding extra speed. On May 29, 1940, VA test pilot Lyman Bullard Jr. took the prototype XF-4U-1 into the air for the first time. The aircraft exceeded all expectations. During flight testing over Connecticut, the Corsair became the first American single-engine fighter to break 400 miles per hour in level flight. Navy observers watched in amazement as the bent-wing fighter outpaced everything else in the American arsenal. The Bureau of Aeronautics was ecstatic. It awarded VA a contract for 584 production aircraft on June 30, 1941. 6 months before Pearl Harbor would thrust America into war. But between the prototype and production, the Navy demanded changes that would turn the Corsair from a dream machine into a nightmare. Reports filtering back from the air war in Europe revealed that the original armament of 2 nose-mounted and 4-wing-mounted machine guns was inadequate against modern fighters. German pilots were armoring their aircraft and installing self-sealing fuel tanks that could absorb multiple hits without exploding. The Navy wanted heavier firepower. They specified 650 caliber machine guns, all mounted in the wings outside, the propeller arc, where they could fire without synchronization. This change required relocating the fuel tanks that had been positioned in the wing leading edges. Bissell had to install a new 237 gallons tank in the fuselage positioned between the engine and the cockpit. The only way to fit this large tank while maintaining the Corsair's streamlined profile was to move the cockpit nearly 3 feet rearward from its original position. This single change made to accommodate a larger fuel tank transformed the Corsair from a carrier fighter into what would become known as the Ensign Eliminator. The first production F-4U-1 performed its initial flight on June 24, 1942. Almost immediately, test pilots began reporting problems. The cockpit sat so far back in the fuselage that forward visibility was severely compromised. The framed birdcage canopy designed for structural strength further restricted the pilot's field of view. During ground handling, pilots could not see directly ahead of their aircraft. During landing approaches, they could not see the runway or carrier deck until the final seconds before touchdown. The massive double-W Wasp engine leaked oil and hydraulic fluid that seeped past the cowl flaps and smeared across the windshield. In humid Pacific conditions, this fluid mixed with salt spray and tropical moisture to create an opaque film that rendered the windshield nearly useless. Pilots reported feeling like they were looking through a dirty window while trying to land on a pitching deck. The aircraft exhibited vicious stall characteristics at low speeds. During high angle of attack maneuvering, the kind required for carrier landings and combat dogfighting. The left wing would stall before the right wing. This asymmetric stall caused the aircraft to snap roll violently without warning. At low altitude, there was no time to recover. The aircraft would simply roll inverted and dive into the ground or water. But the most terrifying problem was the engine torque. The double wasp produced so much rotational force that it could overpower the pilot's control inputs. If an inexperienced pilot added throttle too quickly during a wave-off or go-around, the massive torque would roll the aircraft onto its back. At carrier landing altitudes of 200 feet or less, there was no time for recovery. The pilot would simply roll inverted and dive into the ocean. The first squadron to receive production Corsairs was Fighter Squadron 12, designated 5F-12 in October of 1942 at Naval Air Station San Diego. The pilots were thrilled to receive America's fastest fighter. They imagined themselves shooting down Zeros and becoming aces. That excitement faded quickly as the accidents began. The relocated cockpit created a visibility nightmare during the most critical phases of flight. Pilots could not see over the long nose during takeoff roll, forcing them to S-turn down the runway to check for obstacles. They could not see the landing signal officer during carrier approaches. They could not see the arresting wires, or the deck edge, or the crash barrier. They were flying blind at the most dangerous moments. Young Bensons, fresh from flight training, where they had learned on forgiving aircraft, like the North American SNJ trainer, were suddenly handed the controls of a machine that punished every mistake with death. The SNJ was designed to be stable and predictable, to give student pilots time to recognize their errors and correct them. The Corsair offered no such forgiveness. A moment of inattention, a hand that moved too quickly on the throttle, a slight miscalculation during the approach, and the aircraft would try to kill its pilot. The accidents began almost immediately. Pilots died during training flights when they stalled at low altitude and could not recover from the resulting spin. They died during landing practice when the aircraft bounced over the arresting wires and slammed into the crash barrier. They died during takeoff when the torque rolled them into the ground before they gained enough altitude to recover. They died during formation flying when the poor visibility caused them to collide with other aircraft. The name started as dark humor among the surviving pilots of 5F-12. Someone, no one remembers exactly who, began calling the Corsair the Ensign Eliminator. Ensign were the lowest rank of commissioned officers in the Navy, the youngest and least experienced pilots. They were the ones most likely to die while learning to fly the unforgiving Corsair. The joke was bitter and accurate. It spread through the squadron, then to other squadrons, then throughout the naval aviation community. Within months, everyone in the Pacific Fleet knew the nickname. Within a year, it would become one of the most infamous designations in American aviation history. The Navy continued carrier qualification trials despite the mounting accidents. Porter's tests on the Sangamon were followed by additional trials on the training carrier, West Wolverine, and the escort carriers USS Core and USS Charger. The results were consistently terrifying. Pilots reported that the Corsair was almost impossible to land on a moving deck. The bouncing was unpredictable and violent. The visibility was inadequate. The stall characteristics were deadly. Some evaluators tried to remain optimistic. One official report noted that the Corsair was an excellent carrier type and very easy to land aboard, no different than any other airplane. But the accident statistics told a different story. Corsairs were crashing at rates far exceeding other naval aircraft. Pilots were dying in training at rates that would have been unacceptable even during combat operations. The Navy assigned 5F-17, a new squadron under Lieutenant Commander Tom Blackburn, to become the second Navy unit equipped with Corsairs. Blackburn was determined to make the aircraft work. He established the squadron on January 1, 1943 at Naval Air Station Norfolk and recruited aggressive pilots who were willing to take risks. He worked closely with engineers at VA to identify and address problems. His pilots practiced carrier landings obsessively, developing techniques to compensate for the visibility limitations. Despite Blackburn's efforts, the problems persisted. During the summer of 1943, 5 F-17 conducted carrier qualification trials aboard USS Bunker Hill during her shakedown cruise off Trinidad. The results were maddening. Despite apparently normal approaches, Corsairs repeatedly failed to engage the arresting wires. They bounced over the barriers and crashed into parked aircraft at the forward end of the deck. Blackburn later wrote that his aircraft were strewing expensive debris in all directions, often breaking in two at the engine mount. The first Marine Corps pilot to die in a Corsair during combat operations was not killed by the Japanese. He was killed by his own aircraft. Marine Fighter Squadron 124, designated 5 MF-124, received the first operational Corsair in late 1942. Major William Gies commanded the squadron. The pilots trained intensively at Marine Corps Air Station El Toro in California, learning to handle the powerful and temperamental fighter. By February of 1943, they were declared combat-ready and deployed to the Pacific Theater. The squadron arrived at Henderson Field on Guadalcanal on February 12, 1943. Henderson Field was the most contested piece of real estate in the Pacific at that time. The Marines had captured it from the Japanese in August of 1942 and had been defending it ever since against constant air attacks and ground assaults. The runway was pitted with bomb craters and littered with the wreckage of destroyed aircraft. The surrounding jungle harbored Japanese soldiers who occasionally infiltrated the perimeter to attack ground crews and pilots. The Corsairs of 5 meters. F-124 were early birdcage models with the framed canopy that further restricted visibility. They had the original landing gear oleos that bounced violently on touchdown. They had none of the modifications that would later make the aircraft more manageable. These were essentially the same aircraft that had nearly killed Sam Porter on the Sangamin 4 months earlier. On February 13th, the day after their arrival, the Corsairs flew their first combat mission, escorting Army Air Force's B-24 bombers on a raid against Japanese positions at Kahili. They encountered no enemy aircraft and returned safely to Henderson Field. The pilots were relieved. Their aircraft had performed well in the air, climbing faster and flying further than any fighter they had previously flown. The next day, February 14th, Valentine's Day, 5 MF-124 joined another escort mission. This time, the formation was larger and more complex. Army P-38s and P-40s joined the Marine Corsair in escorting B-24 bombers to Kahili on Binville. It was the longest escort mission of the war in the Solomon Islands at that time, pushing the range limits of all the fighters involved.
Japanese fighters
Intercepted the formation over the target. The engagement became a disaster. The Americans lost 2 Corsairs, 4 P-38s, and 2 bombers. The Japanese lost only 1 aircraft, a Zero whose pilot collided with one of the Corsairs. Pilots who survived the battle reported that their Corsairs felt sluggish and unresponsive compared to the nimble Zeros. The Japanese fighters could turn inside them, could get on their tails, could pursue them through maneuvers that the Kwasa could not match. The engagement would later be called the St. Valentine's Day Massacre. 8 American aircraft lost for a single Japanese fighter destroyed. It was a bitter introduction to combat for the Corsair, suggesting that the aircraft that was too dangerous to fly might also be too clumsy to fight. More pilots died in the weeks that followed. Some were shot down by Japanese fighters who exploited the Corsair's limitations in turning combat. Others crashed on takeoff when the torque rolled them into the ground. Others died on landing when the bouncing gear threw them off the rough runway at Henderson Field. The maintenance crews worked around the clock, patching bullet holes, replacing damaged components, keeping the aircraft flying. But they were fighting against fundamental design problems that could not be fixed with wrenches and spare parts. Lieutenant Kenneth Walsh was one of the pilots who survived those early weeks. Walsh had flown fighters in the peacetime Navy before. Pearl Harbor and understood aircraft performance at a level most pilots never achieved. He recognized that the Corsair had tremendous capabilities hidden behind its dangerous handling characteristics. He began experimenting with tactics that exploited the Corsair's strengths while avoiding its weaknesses. Walsh discovered that the Corsair could not turn with a Zero, but it could outclimb and outdrive anything the Japanese flew. The key was never to engage in a turning fight. Use the Corsair's speed to dive on enemy aircraft from above. Make one firing pass with the 650 caliber guns. Then use the Corsair's excellent zoom climb ability to regain altitude before the Japanese could react. Hit and run. Never turn. Never try to follow a zero through a horizontal maneuver. Walsh applied these tactics with devastating effectiveness. On August 15, 1943, he shot down 4 Japanese aircraft in a single engagement. On August 30th, he shot down 3 more. He became the first Corsair ace, eventually accumulating 21 aerial victories. His success proved that the Corsair could be a deadly fighter in the hands of a pilot who understood its limitations. But most pilots were not Kenneth Walsh. They were young ensigns and lieutenants with minimal combat experience. They did not have time to develop sophisticated tactics before they were thrown into combat. They made mistakes that the unforgiving Corsair punished with death. The official reports continued to blame pilot error. Maintenance logs noted no mechanical deficiencies, but everyone who flew the Corsair knew the truth. The aircraft was killing its own pilots at rates that exceeded combat losses. The Navy faced an impossible decision in the spring of 1943. They had invested enormous resources in the Corsair program. Production lines at VA in Connecticut, Goodyear in Ohio, and Brewster in New York were building hundreds of aircraft every month. The fleet desperately needed fighters that could counter the Zero. But the Corsair could not safely operate from aircraft carriers, which was the entire purpose for which it had been designed. The Grumman F-6F Hellcat offered an alternative. Amwin had designed the Hellcat specifically to address the Zero threat. Incorporating lessons learned from the first year of Pacific combat, the Hellcat used the same Pratt & Whitney R2800 engine as the Corsair, a .BUA, but in a more conventional airframe. It was not as fast as the Corsair. It could not climb as high, but it was easy to fly, forgiving of pilot errors, and most importantly, it could land on a carrier without killing its pilot. In the spring of 1943, the Navy made a choice that would shape the Pacific War. They would give the Corsair to the Marines for land-based operations and adopt the Grumman F-6F Hellcat as the Navy's primary carrier fighter. The Marines were accustomed to making do with equipment the Navy did not want. They had fought on Guadalcanal with obsolete F-4F Wildcats, while the Navy received newer aircraft. Now they would receive the Corsair, an aircraft too dangerous for carrier use. 5. F-17. The squadron that Tom Blackburn had trained specifically to take Corsairs into combat from the carrier USS Bunker Hill received devastating news. Despite months of work developing carrier landing techniques and modifying their aircraft, the Navy was removing them from Bunker Hill. They would be sent to the Solomon Islands as a land-based squadron. An F-6F Hellcat squadron would take their place on the carrier. Blackburn was furious. His pilots had invested everything in mastering the Corsair for carrier operations. They had pushed themselves to the limits of endurance, practicing landing after landing, until they could put the fighter on the deck consistently. They had worked with VA engineers to address specific problems. They had proved that the aircraft could work with the right techniques and modifications. But the Navy had made its decision. Corsair was officially rejected for carrier duty. Blackburn had assembled his squadron carefully, recruiting pilots he believed could handle the demanding aircraft. His executive officer was Lieutenant Commander Roger Hedrick, a skilled tactician who shared Blackburn's confidence in the Corsair. Hedrick would eventually shoot down 12 aircraft and become one of the leading aces of the Pacific War. Together, they built a squadron culture that embraced the challenge of flying an unforgiving aircraft. The Jolly Rogers got their name from the Corsair itself. The Corsair was a pirate, and Blackburn wanted a squadron insignia that matched that swashbuckling heritage. Artist Harry Holmeyer, one of the squadron pilots, designed the skull and crossbones that would become one of the most famous military insignias in American history. The pilots painted the Jolly Roger on the cowlings of their Corsairs and adopted the attitude that went with it. They were pirates of the sky, and they intended to take no prisoners. The decision to remove them from carrier duty was not entirely wrong from the Navy's perspective. The Hellcat would prove to be an excellent carrier fighter, eventually achieving an air-to-AR kill ratio even higher than the Corsair. It was easier to maintain, easier to fly, and caused far fewer fatal accidents. But removing 5 F-7 from Bunker Hill meant that America's fast-tested, most powerful fighter would spend most of the war flying from island airstrips instead of carrier decks. On the evening of November 10, 1943, a young maintenance officer named Butch Davenport sat in the ready room at Odongo Airfield in the Solomon Islands. Ongo, which means place of death in the local language, is a forward operating base for 5 F-17, the Jolly Rogers. The squadron had been in combat for 2 weeks, flying missions against Japanese positions throughout the northern Solomons. Davenport was sketching modifications on a piece of scrap paper. Working closely with VA Field Representative Rostella, he had been studying why so many pilots were dying. The Corsair's left-wing stall was not random, was not caused by pilot error or bad luck. It happened because of the specific aerodynamic characteristics of the wing design. During high angle of attack maneuvering, airflow over the left wing separated before airflow over the right wing. This caused the left wing to lose lift suddenly, while the right wing was still generating lift. The result was a violent roll that no pilot could anticipate or prevent. Davenport and Deva believed they understood the solution. The right wing could be made to stall at the same time as the left wing. The aircraft would mush forward in a controlled manner instead of snapping into an uncontrollable roll. The way to achieve this was to spoil the lift on the right wing slightly, reducing its efficiency so it would stall at the same angle of attack as the left wing. They proposed adding a small strip of metal to the leading edge of the right wing, just outboard of the gun ports. This strip would disrupt airflow over the wing surface at high angles of attack, causing early separation and reducing lift. It was a crude modification that any maintenance crew could fabricate from spare parts. In the field, the squadron mechanics were skeptical at first. Vort's engineers had designed the wing after thousands of hours of wind tunnel testing. They had calculated the airfoil shapes and dimensions with mathematical precision. Who were they to second-guess? Professional aeronautical engineers with years of education and experience, but Blackburn trusted his pilots. He had built 5 F-17 on the principle that aggressive men, who flew combat every day, often understood their aircraft better than engineers, who had never faced an enemy. He authorized the modification on a single aircraft as a test. The results exceeded all expectations. With the stall strip installed, the Corsair's wings stalled simultaneously. The aircraft remained controllable at low speeds. Pilots could feel the stall approaching through buffet in the controls and take corrective action before the aircraft departed controlled flight. The violent snap rolls that had killed so many ensigns simply stopped happening. Word spread through the squadron. Within hours, other pilots demanded the modification for their aircraft. Maintenance crews worked through the night fabricating stall strips from whatever materials they could find: wood blocks carved to shape, bent pieces of sheet metal, aluminium strips cut from damaged aircraft, anything that would disrupt airflow in the right location. Within weeks, every Corsair and 5 F-17 carried the field improvised modification. The improvement in survival rates was immediate and dramatic. Pilots who had been hesitant to engage at low altitude began flying more aggressively. They could pursue Japanese aircraft through maneuvers that would have been suicidal weeks earlier. The Jolly Rogers went on to become the highest-scoring Navy Corsair squadron of the war, destroying 154 enemy aircraft in just 76 days of combat. 13 pilots became aces. Blackburn credited much of that success to the stall strip modification that the team at Odongo had developed. VA engineers eventually examined the field modification and confirmed its effectiveness through wind tunnel testing. A standardized metal stall strip became standard equipment on all production Corsairs, starting with the F-4U-1A model. The official documentation credited engineering analysis for the improvement. The names of Butch Davenport and Russ Devila did not appear anywhere in the records. While American pilots struggled with the Corsair, the British Royal Navy was facing a different but related problem. They desperately needed capable carrier-based fighters, and their options were severely limited. British's designed carrier aircraft like the Blackburn Skewer and Ferry Fulmer were two-seat designs developed before the war to provide navigation over featureless oceans. They were too slow and cumbersome to compete with modern single-seat fighters. The Supermarine Seafire, a nasalized version of the famous Spitfire, had excellent performance but limited range and fragile landing gear that frequently collapsed under the stress of carrier landings. The Americans offered Corsairs through the Lend-Lease program. The British accepted, fully aware of the aircraft's terrible reputation. Their need was too great to refuse. Any fighter was better than no fighter, and the Corsair at least offered performance that could match the best Japanese aircraft. The first Corsairs arrived in Britain in late 1943. British pilots immediately encountered the same problems that had plagued American squadrons. The visibility during landing approach was terrible. The long nose blocked the view of the deck, and the batsman, as British pilots called the landing signal officer. The landing gear bounced violently on touchdown, throwing the aircraft back into the air and over the arresting wires. The engine torque could flip the aircraft onto its back if the pilot added throttle too quickly during a wave-off. But the British could not simply hand the Corsair to land-based units the way the Americans had done. The Royal Navy operated from aircraft carriers. That was their primary method of projecting air power. Their island bases were far from the Pacific combat zones, where the Japanese threat was most acute. If the Corsair could not operate from carriers, it was nearly useless to the British. British engineers and pilots approached the problem with the desperation of men who had no alternative. They had to make the Corsair work on carriers because failure meant having no effective carrier fighter at all. They started with the pilot. Seat. American pilots sat low in the cockpit, their eye level barely above the canopy rail. British engineers raised the seat 7 in, giving the pilot a higher vantage point to look over the nose during approach. This single change dramatically improved forward visibility. They modified the canopy, replacing some of the framework with clear panels to provide a better field of view. They experimented with different canopy shapes and found configurations that reduced the blind spots. They addressed the oil leak problem with characteristic British practicality. American engineers had tried to seal the cowl flaps to prevent oil from reaching the windshield. British mechanics simply wired the cowl flaps across the top of the engine compartment, shut and opened the flaps on the sides. Oil and hydraulic fluid that had previously smeared across the windshield now flowed around the sides of the fuselage where it could not obstruct the pilot's view. They clipped 8 in off each wingtip to fit the aircraft in their smaller hangar decks, which had lower overhead clearance than American carriers. This modification had an unexpected benefit. The shorter wingspan increased the wing loading, which improved the sink rate during landing approach. The Corsair became less prone to floating across the deck and missing the arresting wires. Most importantly, British pilots adapted a landing technique they had already developed for the Supermarine Seafire. In December of 1941, during trials aboard HMS Illustrious, Lieutenant Commander H.P. Bramwell had recommended a curving approach for the long-nosed Seafire to keep the batsman in sight as long as possible. Now they applied the same technique to the Corsair, instead of the traditional straightened approach used by American pilots. British aviators would fly a continuous curved approach from downwind to touchdown. The pilot would begin his approach by flying parallel to the carrier on the downwind leg, then enter a gradual left turn that continued all the way to touchdown. Throughout this curving approach, the pilot could look over his left shoulder and keep the carrier deck in sight. The long nose that blocked forward vision was no longer relevant because the pilot was looking sideways, not forward. He could see the batsman's signals throughout the approach, making corrections as needed. Only at the last moment, in the final seconds before touchdown, would he straighten the aircraft and commit to landing. The technique required practice and coordination between the pilot and the batsman. Both had to understand exactly what the other was doing. But British naval aviators had experience with difficult landing aircraft. They had already developed similar techniques for the Seafire, which had its own visibility problems due to its long nose. Applying the curved approach to the Corsair was a natural extension of existing skills. On June 1, 1943, number 1830, Naval Air Squadron became the first British unit equipped with Corsairs. Pilots trained intensively in the United States, learning the curved approach technique and practicing until they could land the aircraft consistently on the small decks of British escort carriers. By the end of the year, British Corsair were operating successfully from Royal Navy carriers in combat operations. The same aircraft that the American Navy had declared unsuitable for carrier operations was flying from British flight decks and shooting down German aircraft over Norway. British Corsairs provided fighter cover for strikes against the German battleship Tirpitz. They flew combat air patrol over the British Pacific Fleet during operations against Japanese positions. They proved that the Corsair could operate from carriers if pilots were properly trained and aircraft were properly modified.
American.
If the British could operate Corsairs from carriers with their smaller decks and less experienced pilots, perhaps the problems were not insurmountable after all. The modifications that eventually made the Corsair carrier capable for American operations did not come from any single source. They accumulated over months of desperate improvisation by pilots, mechanics, engineers, and administrators who refused to accept that the aircraft could not be fixed. American maintenance crews adopted the British discovery about oleo pressure by increasing the air pressure in the oleo struts. They could make the shock absorbers stiffer and eliminate most of the bouncing that had caused so many accidents. The modification required no special parts or engineering approval. Any ground crew could adjust the pressure with standard equipment. The raised pilot seat from British modifications was incorporated into production. Aircraft starting with later versions of the F4U-1, the improvement in visibility was immediately obvious to pilots who had struggled with the lower seat position. VA replaced the framed birdcage canopy with a clear bubble design that provided dramatically better visibility in all directions. Pilots could see the deck throughout the landing approach. They could see aircraft approaching from behind during combat. They could see the instruments without craning their necks around canopy frames. The stall strip that Butch Davenport had invented in the Solomon Islands became standard equipment. Assembly line workers at Vought Goodyear and Brewster installed precisely manufactured metal strips on every new aircraft. The tail wheel strut was lengthened by 6 in to provide a more level landing attitude. This reduced the nose-up angle during touchdown and improved visibility during the final seconds of approach. Each modification was small. None of them individually would have solved the Corsair's fundamental problems, but together they transformed the Ensign Eliminator into one of the most capable carrier fighters of the war. On April 22, 1944, the Navy officially accepted the F4U-4 shipboard operations following accident-free trials aboard USS Gambia Bay, the aircraft that had been officially rejected. 2 years earlier was now cleared to return to the carrier decks for which it had been designed. The first Marine Corsair squadron to operate effectively from an American carrier was 5 M124, the same unit that had suffered through the St. Valentine's Day massacre more than a year earlier. They joined the USS Essex at Ulithi on December 28, 1944, becoming the first Marine squadron based on a fleet carrier. The pilots who landed on Essex's deck were flying fundamentally the same aircraft that Sam Porter had nearly died testing in Chesapeake Bay. Same engine, same wing, same basic airframe, but the accumulated modifications had turned a killer into a weapon. Major Gregory "Pappy" Boyington took command of Marine Fighter Squadron 214. The Black Sheep, on August 14, 1943, at 31 years old, he was a decade older than most of his pilots and a veteran of aerial combat in China with the American Volunteer Group, the famous Flying Tigers. He had shot down aircraft before most of his new pilots had learned to fly. Boyington received a collection of pilots that nobody else wanted. Some were replacements who had missed their original squadron assignments due to illness or administrative errors. Others had been cast off from other units for disciplinary problems or personality conflicts. The Marine Corps gave Boyington 4 weeks to turn this collection of orphans into a combat-ready squadron. He did it by flying the Corsair harder than anyone thought possible. Boyington pushed the aircraft to its absolute limits and showed his pilots what it could do in the hands of someone who understood its capabilities and respected its limitations. He demonstrated that the Corsair, despite its terrifying reputation, was a magnificent fighting machine. The aircraft was faster than anything the Japanese flew, could dive away from any Zero at speeds that would tear the Japanese fighter apart. Its 650 caliber machine guns could tear an enemy aircraft to pieces with a single well-aimed burst. Its rugged construction could absorb tremendous battle damage and keep flying. Pilots returned from combat with holes in their wings, fuselage, and tail that would have destroyed lighter aircraft. The Black Sheep went into combat on September 23 and immediately proved that the Corsair's reputation as a killer could be redirected toward the enemy. In their first week of operations, they shot down multiple Japanese aircraft while losing only one of their own. During their first combat tour, they destroyed 97 Japanese aircraft. 9% of Boddington's pilots became aces, shooting down 5 or more enemy aircraft. Boddington himself claimed 22 kills with the Black Sheep, bringing his total to 28, counting his victories with the Flying Tigers. He became the highest-scoring Marine ace of the war and one of the most famous pilots in the Pacific. On January 3, 1944, Boddington led a fighter sweep over Raba, a massive Japanese base that dominated the Southwest Pacific. He was trying to tie the American record of 26 aerial victories held since World War I during the engagement. Shot down 1 Japanese aircraft, his 28th kill, before being shot down himself by enemy fighters. He parachuted into the water and was captured by a Japanese submarine crew. He spent the rest of the war as a prisoner, enduring brutal treatment that would have broken most men. The Japanese never reported his capture. For 18 months, the Marine Corps listed him as missing in action, presumed dead. When Boddington was liberated in August of 1945, he returned to a hero's welcome. President Harry Truman presented him with the Medal of Honor that had been posthumously awarded when everyone thought he was dead. The Black Sheep's record stood as proof that the Corsair was never really the problem. The problem had always been asking young pilots to fly an unforgiving aircraft before anyone understood how to make it forgiving.
Ow.
The Japanese noticed the changes in American Corsair tactics almost immediately. Pilots who had learned to exploit the F-4U's weaknesses found that those weaknesses had largely disappeared. The American fighter that used to stall and spin at low altitude now maintained control through maneuvers that would have been suicidal in earlier versions. The aircraft that had been easy prey in a turning fight now rolled with unexpected authority. Thanks to the stall strips and other modifications, Japanese combat reports from late 1944 and early mid-1945 noted that American Corsair pilots were flying more aggressively and achieving better results. Some Japanese aviators initially attributed the change to improved American training or tactics. Only gradually did they realize that the aircraft itself had evolved. The psychological impact on Japanese pilots was significant. For 2 years, they had owned the turning fight. Their A6MO fighters could outmaneuver anything the Americans flew, and they knew it with absolute certainty. That confidence had allowed them to engage aggressively in press attacks that more cautious tactics would have avoided. They could get behind an American fighter and stay there through any maneuver the American attempted. When the Corsair suddenly became competitive in maneuvering combat, Japanese pilots lost their psychological edge. Some became hesitant, breaking off attacks they would have pressed in earlier months. Others compensated by taking greater risks, closing to shorter range before firing, and pursuing Americans into situations they could not escape. Aggression without superiority meant death. By early 1945, the kill ratio had shifted dramatically. Corsairs were destroying Japanese aircraft at a rate of 11-1. For every Corsair lost to enemy action, 11 Japanese aircraft fell from the sky. American pilots flew over 64,000 combat missions in Corsairs during the war. They claimed 2,140 air tour victories against only 189 Corsairs lost to enemy aircraft. No other American fighter achieved a better combat record in the Pacific theater. The F-4U continued to serve long after the war in the Pacific ended. When fighting broke out in Korea in June of 1950, Marine and Navy Corsair were still operational. These aircraft had been in service for nearly a decade, yet they remained among the most capable ground attack platforms available. Corsairs flew from carriers offshore and from land bases in South Korea, supporting American and South Korean troops with bombs, napalm rockets, and strafing attacks. On August 3, 1955, M214, the Black Sheep squadron that Pappy Boddington had made famous, flew their first combat mission of the Korean War. They launched from the escort carrier USS Sicily and attacked enemy installations near Incheon. The same squadron that had terrorized Japanese pilots over the Solomon Islands was now fighting a new enemy with the same aircraft that had served them so well in the previous war. The Corsair excelled in the close air support role. Jet fighters like the F-80 Shooting Star and the F-9F Panther were faster, but they consumed fuel at prodigious rates and could only loiter over the battlefield for minutes. The Corsair could circle above friendly troops for extended periods, waiting for calls for support, then dive in with devastating accuracy. Ground crews loved the Corsair because it was simple to maintain and could absorb tremendous battle damage. Pilots brought back aircraft with holes in wings, fuselage, and tail that would have destroyed more fragile jets. Lieutenant Guy Bordelon became the Navy's only ace of the Korean War, flying a Corsair night fighter. Between late June and mid-July of 1953, Bordelon shot down 5 enemy aircraft, including Soviet-built Leviathan fighters and Yakov trainers that were being used for night harassment raids. He was also the only American ace in Korea who achieved all his victories in a propeller-driven aircraft, a testament to the Corsair's enduring combat effectiveness. On September 10, 1952, Marine Captain Jesse Fulmer was flying an F-4U-4B on a ground attack mission over North Korea when he encountered a Soviet-built MiG-15 jet fighter. The MiG was one of the most advanced combat aircraft in the world at that time, capable of speeds approaching 650 miles per hour, and able to climb to altitudes the Corsair could never reach. Most pilots in Fulmer's situation would have tried to escape, diving for the deck and running for friendly territory. Fulmer attacked. He maneuvered his vintage Corsair into a firing position and sent a burst of 20mm cannon fire into the jet fighter. The Mi went down, its pilot unable to believe that a propeller-driven antique had gotten guns on him. Fighter designed in 1938 had shot down one of the most advanced jet fighters in the world. Other Mi's arrived and shot Fulmer down in turn, but he parachuted to safety over the Yellow Sea and was rescued by a Navy helicopter. The Corsair had proved that even in the jet age, it remained a formidable weapon in the hands of a skilled pilot. The French Navy operated Corsairs during the First Indochina War against Vietnam forces from 1952 to 1954. French pilots flew ground attack missions from aircraft carriers in the Gulf of Tonkin, supporting troops fighting in the jungles of Vietnam. Years before American involvement escalated, the Corsair saw combat again during the Suez Crisis of 1956 and the Algerian War. Some COSA were still flying combat missions nearly 20 years after Sam Porter's terrifying test on the Sangamon. The last Corsair rolled off the production line on January 31, 1953. Goodyear and Brewster had built a total of 12,571 aircraft over 11 years of continuous production. It was the longest production run of any piston engine fighter in American history, a remarkable achievement for an aircraft that had once been considered too dangerous to fly from carriers. Rex Bissell, the engineer who had designed the Corsair around the impossible demands of maximum speed, lived to see his creation vindicated. He remained at VA until the early 1950s, eventually becoming vice president of United Aircraft Corporation before retiring to Sarasota, Florida. He had been right about what the aircraft could achieve. It simply underestimated how difficult it would be to unlock that potential safely. The modifications that made the Corsair great were not failures of his original design. They were the natural evolution of any complex machine. As engineers and operators learned to understand its true capabilities. That is how innovation actually happens in war. Not through clean designs that work perfectly from the beginning, but through desperate improvisation by people who refuse to accept failure. The Corsair earned its nickname honestly. It was an even eliminator. It killed young pilots who did not know how to fly it, whose training had not prepared them for its demands. But it became something greater because men like Butch Davenport, Rostella, Tom Blackburn, and the British pilots who adapted the curved approach refused to let the killing continue. Every modification was a choice. Every improvement represented someone deciding that the next pilot did not have to die. The raised seat, the stall strip, the bubble canopy, the curved approach, the increased oleo pressure. Small changes individually insignificant that together saved hundreds of lives and helped win a war. The final count tells the story. 2,140 victories against 189 losses, an 11-to-1 kill ratio that no other American fighter matched in the Pacific, 64,000 missions flown. Numbers that seemed impossible when Sam Porter climbed out of his cockpit on the Sangamon and told the Navy that their wonder weapon was trying to kill him. The Corsair did not become a legend because it was perfectly designed. It became a legend because imperfect people refused to give up on an imperfect machine. They found solutions that the original designers missed. They invented techniques that no one had taught.